Hello everyone. Today we will see a 8051 program to arrange the given numbers in ascending or descending order using selection sort. So here our program is to arrange the numbers present in the array in the ascending order. First we'll see the ascending order program. Then later we have to change some code and we'll see the descending order. So here we'll be using the memory locations 30H, 31H, 32 up to 34H. That is we are using 5 numbers. You can use more than 5 also, but I am using only 5 numbers. Now here we'll store the data randomly, that is which is not arranged in any order. So we'll take the data as 40, 28, 16, 23 and 9, which is stored at 30H, 31H up to 34H respectively before execution. Once we execute the program, we need to get the answer in the same memory locations, and these has to be arranged in the ascending order, that is 9, 16, 23, 28 and 40. So here we'll be using multiple iterations, that is looping within the looping, and here we need to find out the number of iterations which are required for the complete execution. Initially we'll go for the comparison, and here we'll go for comparing each number with other number in order to find out which number is greater. So first we'll compare. This will be our first pass, that is 40, 28, 16, 23 and 9. This will be our first pass. Here the number which is present at 30H, it is compared with the number present at 31H, that is 40 is compared with 28 and 28 is smaller than 40. Therefore, there is a swap needed. Okay, so here we'll perform a exchange operation. We'll get 28 in the 30H memory location and 40 in 31H location, and remaining numbers will remain same. Now next we have to compare 28 with 16. 16 is smaller than 28. Therefore, again there is a swap needed. So we will get 16 in 30H location and 28 in 32H location, and remaining numbers will remain same. Next, we will compare 16 with 23. Okay. If we compare this, then 16 is smaller than 23. There is no swap needed. So the numbers will remain in the same order. So 16 and 23 will remain in the same order, and these will be the remaining numbers. Next, we need to compare 16 with 9. So here 9 is smaller than 16. Therefore, there is a swap needed, and we get 9 in 30H location and 16 in 34H location, and the remaining numbers will be same. Okay. So here this will be our second pass. So here 9 is in the initial location, that is 30H location. So here we have taken the content which is present in memory location 30H and compared with every content in the higher level. And here we have compared the numbers. If it is greater than the next number, then the number is exchanged. So this is our first round, and it has total 4 steps. Okay. This is our first pass. This is our first round. It has 4 steps, and this will be our second pass. Now we'll take the second pass. In the second pass, this 9 will remain as it is because it is already arranged. Then we will compare the number which is present at 31H location with all the numbers present in other locations in the steps. So first we'll compare 40 with 28. 28 is smaller. There is a swap needed. Therefore, 28 will be here and at 31H, and 40 will be in 32H. And remaining numbers will remain same. Next, again 9 will not be compared because we are comparing the number which is present at 31H location. So now at 31H, 28 is there. 28 will be compared with the number present at 33H location, that is with 23. So 28 it is greater and 23 is smaller than 28. There is a swap needed. 23 will come in 31H location and 28 will come in 33H location. Remaining numbers will remain same. Next, again 23 the number which is present at 31H location is compared with 34H location, that is 16. So 16 is smaller than 23. There is a swap needed. So 9 will remain as it is, 16 will come in 31H location and 23 will come in 34H location, and remaining numbers will remain same. So here now 9 and 16 are been arranged. We have to arrange the last three numbers. Therefore here we have three steps and this will be the third pass. So as the number of passes are increasing, the number of steps are decreasing. Now we will go for the third round. So this will be the data which will take in the third round or the third pass. So here 9 and 16 will remain as it is. Now we have to compare the number which is present at 32H location with the other numbers. So 40 is compared with 28. 28 is smaller. We need a swap. So 28 will come in 32H and 40 will come in 33H. And this number remains same. Next, in the next step, again 9 and 16 will remain in the same location, and 28 and 23 are compared, where 23 is smaller than 28. Therefore, we need a swap. 23 will come in 32H location and 28 will come in 34H location, and 40 will remain as it is. Okay. So here there will be two steps and the numbers are arranged, that is 9, 16 and 23 are arranged. Now we have to arrange these two. So this is having two steps and this will be our fourth pass. Okay. Now in the fourth round, this is our data. So this is our fourth pass. 9, 16, 23 are already arranged. So these will remain as it is. Now we have to compare the data which is present at 33H location with the next number, that is at 34H location. So 40 is compared with 28. So here 28 is smaller than 40. It will be swapped. We get 28 here and 40 here. So these numbers are arranged now. You can see 9, 16, 23, 28 and 40. So these numbers are arranged in the ascending order. So this round is having only one step. This is our final answer. Now next we will see the program. This is the program. So here we'll start with org0000H, which sets the origin, that is the starting address of the program, at 0000H. Next instruction is move R4, 50H, where R4 it holds the array size -1. That is, here we have taken it as the array size as 5. We have taken 5 numbers. So here we have to enter 4 in 50H location while executing the program. That is, array size is 5, 5 minus 1, 4. Next is move R0, #30H. So here R0 it holds the starting memory location of the array. Then we'll come to the outer loop, that is labeled as L1. So here move B, R4, it copies the contents of R4 into the register B, and R2 it is used to track the comparisons with within each pass, and move R2, B, it will copy the contents of register B into the R2 register, and the number of comparison in each pass will decrease as sorting progresses. Next you have move A, R0, which loads the contents of R0 into A. Then you have increment A, which increments A to point to the next element in the array. A is the accumulator. Then you have move R1, A, which stores this incremented value in the R1 and making R1 point to the next element. Then you have the inner loop, which is used for comparing the adjacent elements. So it is labeled as L2. You have move 10H, at R1. At R0. So it stores the first element into the temporary storage 10H. Then you have move A, at R1, which loads the second element into the accumulator, which is present at R1. Then you have CJNE A, 10H, L3, which compares the second element which is present in the accumulator with the first element which is present in the 10H memory location. Now, if the contents of the accumulator, these are not equal to the contents present at the 10H memory location, it jumps to L3 to check the swapping conditions. Then this is used for swapping L3. So L3 is level which is given to the swapping logic here. So JNCDN, jump if no carry. It means that if the contents of the accumulator are greater than or equal to the contents which are present at 10H location, no swap is needed. The elements are in order, so we have to jump to DN. Okay, and if the contents of the accumulator are less than the contents which are present in the 10H memory location, then the carry flag is not set, so so we have to swap the elements. Then we have ex move ex move at r0 comma a, which moves the contents of the accumulator, that is the second element, to the first position at r0. Then you have move at r1 comma 10H. It will move the contents which are present at 10H memory location, which are previously stored previously stored the first element to the second position at r1, and this will swap the two elements. Then you have dn label, which is used to move to the next pair, this loop. So here you have increment r1, which moves r1 to the next adjacent pair for comparison. Then djnz r2 comma l2, it decrements r2 and loops back to l2 until all the comparisons in the pass are completed. Then you have to proceed to the next pass. So for that you have to increment r0, which moves r0 to the next element to start the next pass. Then you have djnz r4 comma l1, which decrements r4 and loops back to l1 until all the passes are completed. Then you have to halt the program where sjump this colon h colon sjump h, it will create an infinite loop to stop the execution once the sorting is done, and end will mark the end of the program. So here we will take the input, that is we are taking 5 numbers. So the array size is 5 here, that is 1 2 3 4 and 5. Okay, 5 data we are taking, that 5 numbers, and at 50H we will be entering the array size minus 1, so that is 4. Here the number of the size of the array is 5, so here at 50H you have to enter it as 4, and the output is this, that is you will be getting the numbers arranged in the ascending order. So now we will see the program. I will copy the program from here, Control C. Now we will go to kill, maximize this. Okay, go to project, new vision project. I will use the previously used project as usual, that is Alice. Save. Yes. Now you have to select microchip device, and from here you have to select 8089 C51, or directly you can search for 8089 C51. So 8089 C51. Okay, then you have to click on no. Now you have to go to file, new file, write down your program, that is type the program. I'll directly copy the program here. You have to save the program. So I will save it as I'll save it as select, because it is selection sort. So just I'll give the name as select.asm. Save. Now it is saved. Now go to the target 1 in the project window here, click on this plus sign. You will get source group 1. Right click on this and you have to click on add existing files to group source group 1. Select your program. We have given the name as select.asm. Add and close. Now see whether it is added to source group 1 or no. So it has been added. Go to project, build target. So you are getting 0 errors and 0 warnings. Go to debug, start or stop debug session. Okay. Now here you want 2 memory locations. We are having 1 memory location. I will take here I:50h because I want to enter the array size -1 here, and one more memory window I'll select to enter the array. So the array has to be entered at 30h, I:30h. So here what are the numbers which we have taken in the program while explaining? That is in 50h memory location I'll enter it as 4 because I'm taking 5 numbers. So the array size is 5. Here you have to enter it as array size -1. So the numbers are 40, 28, 16, 23 and 9. Okay. Now we will run the program. Run. So you can see here the numbers are being arranged in the ascending order, that is 0, 9, 16, 23, 28 and 40. So this is the program for ascending order. Now we will see the descending order. Stop this. You have to make a slight change in this program. Here you have J and C. Just make this as JC. Okay. Now go to project. Rebuild all the targets. So you are getting 0 errors and 0 warnings. We go to again debug. Start or stop debug session. Okay. At 50h memory location, we will be entering array size -1, that is 4. And at 30h location, we will enter our data 40, 28, then you have 16, 23 and 9. You can see here this array is not arranged in any order. Now we will see whether it will be arranged in the descending order. Go to debug, run. So you can see it is arranged in the descending order, that is 40, 28, 23, 16 and 9. Hope you have understood the program. Thank you.